All right, so today, obviously, the unit says exponential and logarithmic. We're going to take that bridge from exponential into logarithmic. We're going to talk about reteaching of basic logs. So if you take a second, just on the top of your notes, number 1 through 8, and see if you can just jot down the answers. You don't have to write the problems down. This isn't an actual quiz. Look at it, jot the answer. Look at it, jot the answer. Put a note in the comments that you came in late. Okay. We just started the new section. All right, so here are your answers. Quick check. 3 to the third is 27. 16 to the 1/2 is 4. 3 to the negative 1 is 1/3. 4 to the negative 2, 1/16. Negative 2, not in parentheses, raised to the third power is negative 8. 27 and 2 to the 2/3 is 9. 5 to the 0 is 1. And negative 4, again, not negative 4 in parentheses, raised to the second power is negative 16. Which ones do you have questions on? Yes. Okay. So, in number 2, these are rational, meaning fractional exponents. Okay. Anytime you see those, that means they are going to involve a root where the base goes on the inside. The denominator is the index of the root, and the numerator is the power of the base. So I'm asking you in that question, what's the square root of 16? Okay. So now when we come down and we follow that same pattern, in number 6, I'm asking you to evaluate a root. 27 is the base. The denominator is the index. The power is the numerator of the base. So now you can look at this and say, all right, 27 is 3 times 3 times 3, right? Another 27 is 3 times 3 times 3, and I'm looking for triples to get out of medium security square root tail. In this case, cube root tail. Gives you 9. Why would number 8 be positive? Okay, so we did an example kind of like this yesterday. Negative 4 squared versus negative 4 squared. Right? If I put a 10 in front of here, does it make sense that I would be subtracting 16? That's why. Whereas here I'm taking what's in the quantity and squaring it to get positive 16. So we just made a general statement that said if there's no parentheses, the base is simply the 4, and the negative indicates a subtraction sign. Because we don't write plus 4 squared, it's just the number squared. Other questions? All right, review questions. We're going to skip these because you just did a different warm-up. All right, so let's talk about logarithms. Logarithms are written in a very specific form. They are like functions. They have a notation to them. We use the word log in its shortened form, base A of x. Now, what's tricky about this is that everybody sees base A, and they see the x, and they know logarithms have to do with exponents, so they think base to the power, because that's how we write things, don't we? Like a to the x. But this is not the format. This is a little tiny baby a down here. This is a large x. That is not a raised to the x power. That's the first thing we need to overcome thinking when we make these connections. A has to be a positive constant other than 1. And we also want x to be positive. We're going to talk about why that is once we break down what the definition of the logarithm is. When I ask you to read this problem, we're going to work on reading them because it cements what they actually are. This would be the logarithm base a of x. And you need all of those transitions in there. The logarithm base a of x. Okay, that's what we have written right here out in English. The translation, so what you should think of, this is what some of you are missing in your math vocabulary, is this means the exponent of a that gives you x. So logarithm right here means exponent. What is the exponent of a that gives you x? Reading it out loud, logarithm base a of x. Okay, whenever you see the word log, you should interchange it with exponent. Exponent of. That's the big idea. So let's practice reading these. First day you walk into college, your professor throws this up and says, okay, somebody read this out loud to me. What are you going to say? Not me. No, it's very simple. How would I read that mathematical statement correctly? Any volunteers? Go ahead.
Say 2 to the what power equals 8.
Okay, that's what you should think. But how would you read this statement? Go ahead. Close. The logarithm base 2 of 8. You want to use the whole expression. Okay? So this formally is read as the logarithm base 2 of 8. In your head, you're going to think, say it again, AJ.
2 to the what power equals 8.
What is the exponent of 2 that gives you 8? And the answer is, you all right?
Yeah, I'm sorry.
You could probably pull the lines down maybe a little bit. I don't know. Would that help? Okay. What is the exponent of 2 that gives you 8? 3. Okay. All right, let's move on to the next one. Any volunteers to read this one out loud formally? Think. Professor calls on you. You have to do this in the middle of class. How would you read this answer? Go ahead.
Logarithm base 3 of 27.
Logarithm base 3 of 27. In your head, what should you be thinking, though? Not necessarily saying out loud. Right, what is the exponent of 3 that gives me 27? And the answer is 3. Right, next one. Read it formally. How would I read that formally? The logarithm base 2 of 1/2. In your head, you should be thinking, what is the exponent of 2 that gives me 1/2? Okay, now, just as we've talked about this, the exponent of 2 that gives me 1/2, 2 moves to the denominator, which tells me the exponent is negative, right? And what is the power of 2 that gives me 2? 1. So the answer would be -1. Okay. Here's the idea for those of you that haven't caught on. Plus 5 is equal to 11. What goes in the blank? 6, right? That guessing game that you're playing with addition is the same as what we're doing here. We're just doing it with logs. We're doing it with exponents. What is the exponent that gives me 1/2 if the base is 2? Same exact idea. Just a little bit ramped up, higher level thinking. Next one. Read it formally. The logarithm base of 16. Whoever watches this video is going to think I'm in a classroom of 3 people. Logarithm base 4 of 16. What is the answer? 2. What is the exponent of 4 that gives me 16? The answer is 2. All right, next one. This is not a trick, even though it looks really, really weird. What is the logarithm base 3 of 1? 0. Okay. 3 to the what power gives me 1? This is a law of logarithms and exponents, which is 0. Anything to the 0 power generates a 1. Okay? Now, while we're on this example, I want to take something out here. Do you remember the definition? We always said this value has to be positive. It's because anytime I take any base which starts out positive, I can never change its sign using exponents. So if you have a logarithm base 3 and there's a negative in here, the answer is no solution. You can never ever have a negative in what we call the answer spot. Right? Here's the answer we're trying to generate. The log is the short term for what is the power. You can never use an exponent to change signs of a base. Ever. Right, so we touched on that. Let's move on. How about this one? This one, if you don't know it or see it right away, you might want to write it down. Logarithm base 16 of 4. What am I asking you to do? I'm asking you what is the power of 16 that gives me 4. Now, first thing, the common answer everybody always tells me is 1/4. Right? The problem with 1/4 is that's multiplication, that's not exponents. 16 times 1/4 is 4, but I didn't say 16 times x, I said 16 to what power? So here's the general rule with logs and exponents. If you take a big number and you tell me that what comes out is smaller, the only way to make it smaller is to use roots. So what I'm saying is square root of 16, 16 to what power gives me 4? What's the exponent form of that? What's the index? 2. What's the power? 1. So that tells me that this value has to be 1/2. The only way to take a base and make it smaller, with the exception of the 0 power, is going to be using some sort of a root. Okay, and obviously the ones I'm going to give you, you're going to be able to think out. Now, I also would like to propose this. For those of you who have some familiarity with this, 16 to what power gives me 2? What is 16 in base 2? 2 to the what power? 2 to the 4th times this block, right, is equal to 2 squared. You see how I also can generate 1/2 from that? That if the bases are the same, the exponents have to be the same. Like instead of this, if I call it x, 4x is equal to 2. X is 1/2. Another alternate method, we'll get to this later when we get to some more equation solving. How about log base 5 of 1/25? -2. -2. You're thinking in multiplication, but remember we're dealing with exponents. -2. Question? Yeah. The index is always 2 on a square root, yes. And if there's no power on the inside? Are we good with -2? Yes? Okay, then we move into this form. Log base 10 of 100. 10 to what power gives me 100? Close. 2.
Oh wait.
Somebody said 10.
I did.
2. 10 to what power gives me 100? It is 2, not 10. Okay, now, this is our transition to kind of our first part of the actual lesson, not so much review. Here it is. We do not write log base 10. Okay? This will be written moving forward as just log of 100. There is no base written there. If the word log is there with no base, it is understood to be 10. Got it? So in your thinking, even when you read it, it's logarithm base 10 of 100. But there's no base written there. Correct. It's understood. Okay? All right, now, do you have these examples in your notes? Is this where your notes start? Yes. Okay. So finding certain logarithms, this is our first part. Find each of the following. 10 to what power gives me 10,000? Count the zeros. How many zeros? 4. So it's 10 to the 4th. Okay, so the first answer is 10 to the fourth. What about 10 to the 0.01? If I'm giving you this without a calculator, you want to convert this into 1 over 100. So 10 to what power gives me 1 over 100? Negative 2. You don't have these?
No.
Okay, so just pay attention. Not difficult. 2 to what power gives me 8? 2 to what power gives me 8? 3. Moving here. 9 to what power gives me 3? This is an example of taking a base and making it smaller. So it's going to involve roots, which involve fractions ultimately. This is going to be 1/2. Does anyone have a question why 9 to the 1/2 gives you 3? If it doesn't make sense, ask. Yes. Well, if it was 27, couldn't it be 1/3? Like, what if I had 27 equals 3? That would be 1/3.
Are you trying to find out the index of this word?
All right, 6 to what power gives me 1? 0. 8 to what power gives me 8? 1. Does anyone have a question on any of these 5? I will re-explain them. I will break it down. I will speak again. I will make no faces. Any of them? Yes.
E0.
I said what?
E0.
Oh, yes. 6 to what power gives you 1 at 0? Okay, so now let's go through these. These are the answers. We did all that. Okay, common logarithm. This is what I just spoke about. If there's no log written there, we're going to assume it's base 10. So if I ask you to evaluate log of 100, it means log base 10 of 100. 10 to what power gives me 100? 2. Anytime you have a decimal given, you want to convert it into a fraction. 10 to what power gives me 1/10? -1. Good with that. Anthony, are you good with that? Because you said you never saw any of these before. Good? All right, moving forward. All right, find each of the following common logarithms. Please pull out your calculator. All right, calculator, real quickly. And I want you to type them in. So you have 2 buttons you need to be familiar with. You have right here log, and you have ln. We're going to use the log button. Put in the log. We're not in Kansas anymore, kids. You're like, I don't care how many times it slams. I want that cold air. Oh. It's supposed to be really bad. We're supposed to get like 2 inches of rain today. It's going to be bad. And I have bus duty. It's fantastic. I had it yesterday when it was raining. It was fantastic. 3 weeks of waving goodbye to everyone. Get on your buses and go home.
I swear you're like waxed on.
All right, so in A, when you put in your calculator, tell me what the calculator tells you, because this is not the fun part of today. It's very easy. Put it in. What does it tell you?
5.1.
All right, so you get this guy right here, something like that. Magic calculator. All right, so here's the kind of test question I would ask you. You sit down to your calculator, you put this in, you get that answer out. What does it mean? But the calculator, yeah, what is the calculator? What does the answer mean? Yes. What did you say? Yes. If you look back here, we're asking the question of the calculator, what is the exponent of 10 that generates this? The answer would be 10 to the 5.81 blah, blah, blah. If you put that in your calculator, it would give you 645,778. Does that make sense?
Yep.
So think about, I know it's just decimals in and out and you're just typing things in, but you still want to reflect on what the answer gives you. If I do that for the second one, you can write this answer down. Log of 0.40239. The answer comes out to -0.6216. Here's my question for you. Why does it make sense that that's a negative? Yeah, if you look at this original problem, the base is 10. I took 10 and I turned it into a fraction of 1 over something, right? That's got to be a negative. It's the only way to turn it into a fraction and make it smaller in fractional form. Right now, next one. Let's see who can do this one. Letter C. You put this in your calculator, you get error. Why? Why does the calculator give you error? Because I guarantee someone's going to say, I'm putting this in my calculator and it's giving me an error. I don't know why. So let's answer that question right now. Can I ever get a negative in this answer spot right here? No. Can I ever use 10 up here, use a power, and generate a negative number as my answer? No. That's illegal. It doesn't happen. Therefore, the logarithm doesn't exist. There is no answer to the problem. Okay? Now, moving on. This is the one that a lot of you forget about. It is ln. ln is natural log. It's actually, those of you who take French, log naturel. Anybody take French? Not one person in this room takes French. What are the odds of that? Well, it's probably a scheduling thing. Log naturel comes from natural base E. The natural log, remember we talked about base E yesterday? 2.72. Yes? So when I see ln x, it means log base E. This is really important for those of you that are doing that translation in your head. So when I read this, it would be the natural log of x. That's how I would read this, even though it's ln. What is the natural log of x? However, what I'm thinking is I want the exponent of e that gives me x. This translation is important. Okay? So if I look at example 1, I'm saying what is the logarithm base e that gives me 1? E to what power gives me 1? What? 0. Anything to the 0 power generates a 1. Don't forget, you have one more step in the translation. E, think of it as 2.72. So 2.72 raised to what power gives me 1 if you want to go to all numbers? Okay, E is just a placeholder for that value. Think about that long decimal. Now, example 5. Those of you that are rewatching this video, this is probably the most important part of getting the problems correct that you have to think out involving E, and here it is. If you notice, I'm going to write ln, and I'm going to write E in blue. The E that I just highlighted in blue is in the answer spot. What is my base? E. So technically, this is going to be log base E. That's what you should be thinking of E, and I can even make that to the first power, because now it makes sense when I think it out. What is the exponent of E that gives me back E to the first power? 1. Got it? Barely? Barley. Okay, so real quickly, you have these in. You don't have to put them in because I'm going to give you the answers. If you pick up your calculator and you would type in over here ln, and you would put in the same number, 645, 778. You plug this into your calculator. The answer that comes out is 13.3782. What does that answer mean in terms of the original problem? E to the 13.38 is going to give me 645, 778. Doesn't it make sense that number would be bigger now because my base is starting smaller at almost 3 instead of 10? That this would be a bigger number than the last example? Okay, if I look at the next one, same thing. Notice it is a decimal. Therefore, I got a negative, which made it think 10 to the negative 1 is 1/10. It gave you a fraction out, so the negative makes sense. Why would the negative 5 generate an error? ln of -5, natural log of -5. In the answer spot, I can never have a negative. Okay, so these are things you're putting in the calculator, understanding what the answers mean. Again, natural log of e, why would it give me a 1? What was the question you were asking the calculator? E to what power gives me e to the first? 1. Make the connections between the calculator and the other. And then in this case, ln of 1 is always going to be 0. E to what power gives me 1? 0. Good? Okay. Now for the most fun, important part. I return to the left side of the board. Does this make sense?
Yes.
All right, everybody pay attention, please, because we're about to make the transition, what you're going to need for the next 3 lessons right now. Y is equal to 2 to the x is equal to this. Okay? All right. If you take a look at my next equation that I have here, I have y, I'm going to replace this, y is equal to log base 2 of x. Do you see how a is 2 in my example here? Yes, my base was 2, so my base is 2 here. Okay, here's your big moment. Logarithmic equations are the inverses of exponential. So what that means is take this same exact chart that I have right here, and I set up my x and y. What I'm feeding in now are not the x's, I'm going to feed in the y values. So for instance, 2 to the first power gives me what out? 2 to the first is 2. 0, 1, -1, 1/2. All right, now we have to take an aha moment and think about that. Is there anyone that doesn't understand why I was able to do that with my table? You probably understand inverses, that they're inverted, but my question is, can you make the connection between what's in here and what it says right here? That's what you have to be able to do after tonight's homework. Yep.
How did you get y equals 2x for the red part?
2 to the x.
Yeah.
How did I come up with that table?
The answer for y equals 2 to the x.
That's the graph of y equals 2 to the x.
Oh, that's like the standard way.
Yep.
Oh, okay.
Yeah, so what I did is I just chose a base that was very familiar to everyone, 2 to the x, and I picked 3 points for the sake of time, and I plotted them. Okay? Then I went down and I said, all right, now I'm going to show you that the inverse is going to be this equation here. All right, so here you go. For those of you that are like, I think I'm getting it. I know she inverted it. I'll go back and watch it. Here's the idea. If y equals 2 to the x is the original equation, wouldn't the inverse be x is equal to 2 to the y? So look at my table. 2 to the first is what? 2. 2 to the 0 is 1. 2 to the -1 is 1/2. What I need you to do is connect this. That y is equal to log base 2 of x means what is the exponent of 2 that gives me x? It's the y values. So you're literally substituting in the y's to figure this out. You're going to say, okay, well, that's fantastic. Well, if I take this and I now graph it, take a look. 2, 1 is going to be right here. 0, 1 is here. 1/2, -1 is here. This is the graph of y is equal to log base 2 of x, or x is equal to 2 to the y. Same thing. One thing that's important to note, this is now my key point right here. Also, I do not have a horizontal asymptote anymore. I now have a vertical asymptote right here. Graphically, it is the inverse. So this is 2 to the x. This is log base 2 of x. Questions on that? Please do not draw this part of the graph. This is the graph of the exponential. This is the graph of the new function that we have right there. So what I have in blue is what's graphed here. All right, take a look at your homework sheet, please. Homework number 31. I would only like you to complete through 41. When you come in tomorrow, we'll finish the notes and you'll finish the homework. I'd rather you be here for that because what I found is this transition to these new graphs. Some of you it takes you a little longer for that to settle into your brain. So I'd only like you tonight to do through number 41 on homework 31.